Open up the new packets. Section 3.5. Game on. Come on. Come on.
You can do it. I believe in you. I know Solomon doesn't, but I believe in you.
Mr. Sullivan,
Hey.
can I fill this water up?
Okay. Ooh, yeah, Frank is extra slow today.
You probably had a mental breakdown, buddy.
What's going on?
Talk about it.
He's getting sad because he's.
I've heard I'm a great therapist, but not to myself.
That's typically how it goes. But
Oh, being perfectly honest, Frank can kiss the darkest part. Mm-hmm.
I don't think you should finish that sentence.
Elise, that's what's going on.
Oh, that's okay. So, yeah.
Functional graph analysis, beginning of pre-calc.
Great.
Which, you know what? That's not bad as a segue into what we doing. Because, remember in first semester when we were doing graph by table, there's a good chunk of you that got grumbly about it and said, but I know slope-intercept, why should I have to do a table? It's stupid. Because it ain't always a line. Turns out, there's a bunch of weird graphs out there. And we got to know how to graph by table in case we run across one of those weirdos. It's kind of like carrying mathematical mace in your pocket. You always got an option. Okay? I need to graph things that sometimes get funky. Now, everyone here needs a calculator that has parentheses on it, not your phone. Because you need to be comfortable and confident with this when it comes time for a test and you can't use your phone for a test.
That's why we're by this.
Just lately off subject, you know those fruit pouch things you got? The freebie cabinet? You're the only reason why I'm going to be able to eat vegetables now. Because I have to buy those.
So, first, I want us to think about how big squares get. Y'all remember where exponent button is? If I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, it's not that much of a change, right? If I count by multiples, say I count by fives, 5, 10, 15, 20, 25, 30, 35, 40, 40, it gets big, but not at a crazy rate. I want you to, in your calculator, what happens when I go 3 squared? Versus 7 squared. Versus 17 squared. See how big that gets and how fast it happens? Goes from 9 to 49 to 289. Because of that, you ever see a movie that's like they're near a black hole or something, or you see an animation of one where it kind of getting sucked into the black hole, it's kind of curves. Maybe you've talked about this in your science classes, how a black hole will actually curve light. It pulls light in a curve like that. Exponents are more powerful than multiplication or addition. And because of that, we're going to start getting funky graphs like, Frank, you're ruining my punchline. That guy. Down in that bottom right corner, you know how we always have that kind of blank space? We're going to write something. It's all in the vocabulary section there, but maybe you want to put it in your own words. A quadratic. Okay, they got the spelling of it right there. A quadratic. Sometimes kids get a little confuzzled on that because they hear quad in there. Quad means 4. But quadratic is anything with x squared. Okay, so if it's got x squared in it, it is now a quadratic. Now, that's the name of the equation. I should say anything, any equation with x squared. A parabola is anything that is the graph of a quadratic. Okay, so kind of like if I see a linear equation, y equals mx plus b, technically it's called the identity equation. And then the graph of it is called a line. Yep, should be 3b. So the equation itself is called a quadratic. Its graph is called a parabola. Anyone heard those words before? Okay, probably heard of quadratics, but parabola, not parabola, parabola, it's a funky U shape, right? And it's because those squares, they get bigger and bigger and bigger faster than a line would ever move them. So it goes to 1, then it goes to 4, then it goes to 9, then it goes to 16, and it curves inward like that. If I were to make this thing bigger and bigger and bigger and bigger, it's still going to have that U shape to it, but it's going to go up a lot faster than it goes out. There's tricks to graphing these, but those tricks involve a lot of mental math and involve knowing your squares and knowing your knowing different transformations, which we don't even got yet. So we're going to fall back on that can of mathematical mace in our pocket. I can graph these by table. And that's why you need to have a calculator. That's why we needed to practice graphing by table in first semester, because sometimes you run up against weirdos. Okay? They got some features. The bottom of it here, where it switches directions, that is called a vertex. It's the point. Well, actually, it should never be pointy. We're going to do absolute value graphs. Those have a point. This is just the bottom of the hill or the top of the hill, depending on, sometimes the graph goes like this, right? So whether it's like that or like that, it's a vertex. Last time you probably heard that was in, what, middle school? Remember doing like geometric figures? And the points where you switched directions, each of those was a vertex, plural called vertices. So this is a spot where my graph changes directions. It's called a vertex. Okay? It can be the highest point or the lowest point on a graph. What do you call the highest or lowest of a thing that you can have? Interesting. Yes, but all right. What's the highest number of absences you can have before you have to pass the final? 5. So you would say the maximum number that you can have is 5. Okay. To pass a class, you need to have at least 60%. So that would be called the minimum grade that you need to pass a class. These are called maximums and minimums because they're the highest or lowest point on the graph. Okay? Additionally, scroll down a little bit here. Frank. Wherever this graph hits the x-axis, we've dealt with y-intercepts, right? Wherever it has x-intercepts, where it hits the x-axis, those are called my solutions. And it's got a bunch of different names. I can call it a solution. I can call it an x-intercept. Later on, I'm going to call them zeros because everywhere on the x-axis, isn't that a coordinate for 0? It's a coordinate negative for 0. I set y equal to 0, and I solve. So they've got different names depending on different contexts. If I'm talking about the equation itself, I call it a 0, or I call it a solution. If I'm talking about the graph, I call it a 0, or an x-intercept. If I'm talking about larger polynomials, I'll call it a root. You all have different names depending on the context. I want you to think about it. Okay, we'll pick on Marcus. Okay. I see Marcus walks into class, say, "Hey, what's up, Marcus? How you doing?" Okay. I'm gonna call him Marcus. If he walks into Grandma's house, maybe she says, "Hello there, Moon Pie." Okay, got a cute little pet name for him. Maybe he walks into his friend's house and they say, "What's up, Bump?" Okay. Depends on the context. It's still him, right? These have different names depending on the context. It's all still the same object. It's where it crosses the x-axis. Okay? So it's still Marcus. It's just who's talking to him. Okay? So we're going to use those words kind of interchangeably. They just have a little bit different context. Sometimes a parabola can hit a x-axis a different number of times. That's what's on this first page here. Frank? Sometimes we call it a smartboard. Sometimes we call it Frank. Sometimes I mute my mic and I go off. Okay. So there's my parabola. If it looks like this, how many times does it hit the x-axis? Twice. So I'd say it has two solutions. And then I'll tell you what those 2 points are. Sometimes it just bullet grazes it, just like pings off of the axis, like a bouncy ball. It only hits it in one spot, it's only got one solution. Sometimes a parabola is going to be hanging out back here. No solution. Okay, we're seeing this more and more, right? Where the answer is there isn't one. So this is all vocabulary that we need to keep track of. I want you to have it all down here that a quadratic is an equation with x squared. A parabola is the graph of x squared. That the vertex can be a maximum or minimum where it changes direction. And then solutions, x-intercepts, and zeros are where it hits the x-axis. maximum, minimum, where it changes direction. Okay? There's a lot of vocabulary at the beginning. But when was the last time we saw a graph like this? Okay? Maybe you had to graph them by table a long time ago, but you haven't seen them since. The back half of Algebra 1 is supposed to hammer the living snot out of quadratics. There's a bunch of stuff you can do with them. In fact, there's so much stuff you can do with quadratics that we don't even show you all of it in Algebra 1 and 2. Kids come up to me in pre-calc and then I say, oh, hey, by the way, turns out there's more. It's like when you get older and find out that that one uncle wasn't really your uncle, it was actually your dad and you were adopted or something. Okay? It's like the big revelation later. I don't know, maybe it's Arkansas. Okay? Your brother cousin. We won't. No, we won't go there. Or Louisiana. So, there's a bunch of stuff that you can do with parabolas. We're going to do the bare bones today, where I'm going to ask you to tell me this vocab stuff when you look at the graph. So it's already going to be there. You just tell me stuff. Or I'm going to ask you to graph it, and we're going to do it by table. And that's why I need you to have a calculator that has parentheses that you're okay using later. Okay? Before I flip the page and do those, a couple of things. A, did everyone pick up their packets if you turned in your packets? I put them on the back table because my counter is kind of a mess. You need to have, if you did not turn in your packets, and that's the number one thing, I don't know if anyone looked at the update I sent out to parents, I also sent it out on Remind. The number one thing with our grades in here isn't I have no idea what's going on, it's I never turned it in or I don't pick up the pencil. Y'all, I know everyone here is capable of seeing better. You just gotta pick up the pencil and ask questions. Okay? So pick up your packets. If you don't want your packets and they're still here come next week, I'm just gonna throw them. Remember, it's open notes, open everything come time for a final. I know you put stuff in there that might be handy to you, like those cheat sheets for which direction graphs go, and whether it's open circle or closed circle, ands and ors kind of stuff. Maybe a good idea to have them. Okay. Pop, pop, pop. All right, here we go. Graphopha. Y'all remember Facebook math? I talked to you about the order of operations and how, like, Aunt Kathy's going to argue with someone on Facebook about whether who's right and who's wrong about the thing. Okay. Example would be like if I said, what is 27 divided by 3 times 9? What is that? Without a calculator. Without a calculator.
It's one.
81.
It's
Oh,
one.
wait. No, because we gotta do order of operations.
No, that's fake.
I did it on the calculator. 27.
PEMDAS.
1. It's just 1.
4.
I'm not hearing any arguments of why. I'm just hearing people yell numbers. You're not right just because you yell louder. Someone explain it.
It equals
I'm
one.
guessing we gotta do order of operations.
Okay.
My God.
And this, it's 81 because the calculator said. It's 27 because the calculator said. Okay? It depends. It depends on whether you understand those order of operations or not. Tell me what they were again.
Exponents, multiplication, division, addition, and subtraction.
It burns in my brain.
Was it really?
Yeah.
Yes.
Was it burnt in correctly?
That's a great question.
Yes.
Probably not. Probably not.
Okay. Divide a thing. There is no such thing as division. I can't prove it mathematically because it's not enclosed by an algebraic structure. That's in a math class that you would take, hold on, geometry, algebra 2, algebra 3, pre-calc, calc 1, calc 2, calc 3, diffie-q, non-Euclidean, topology, discrete math, abstract algebra. 11 classes after where you're at right now, you would prove why that is.
So you're telling me when I had to learn long division, it was all just a lie, and I had to suffer for no reason?
Because I don't really subtract. I add the opposite.
That's ridiculous.
Remember, adding a negative is the same as subtracting? So subtracting is the same as adding a negative. I don't really divide, I multiply by the reciprocal.
You're telling me I had to learn longhand division and suffer countless hours.
So do you have next to these, multiplication, division are supposed to be done left to right like a book? Because they're the same thing. Do you have addition, subtraction is supposed to be done left to right like a book? Because they're the same thing. And that's where we're so used to PEMDAS. And this is why people will argue about it in the comments section. And someone's going to say, well, that's 27 divided by 27, because you're supposed to multiply first. Duh. And then they'll get 1. But what if I told you, oh, and then someone else will come along and they'll say, well, that's 27 divided by 3 times 9. No. This assumes a set of parentheses. That's divided by 3 times 9 together like that, because by putting them on the denominator, I'm forcing them to be done first. And then it turns out this was a lie. It's actually 27 times 1/3 times 9, because division is a lie. I don't divide by 3, I multiply by 1/3. That's why I have to do them left to right like a book.
So when you're making my brain hurt.
The answer is yes, Marcus.
Yeah.
The answer is 81.
What? I feel lied to.
Because you're supposed to do it in the order of operations.
Yeah, I did do it.
This divide by 3, it's not real. It's just something we told you to make you feel better when you were little, like the tooth fairy. I'm multiplying by 1/3.
I'll let you know what the tooth fairy was? I never got told that.
27 times 1/3 is 9. 9 times 9 is 81.
Bro, my parents never told me about the tooth fairy. They just took my teeth and gave me money in exchange. Y'all are weird.
Get the mental image of Leslie as a kid, just like with pliers, like, $5. $5.
I mean, you're not wrong.
Okay. So,
You're not right.
the reason I bring up all that PEMDAS stuff, the reason I'm bringing up the order of operations, is because, everyone with your calculators, double check for me. First, without the calculator, what is -3 squared?
A number.
9. No.
What does squared mean?
2. Times it by 2.
Not times 2, times itself.
-3 times -3.
Okay, I said -3 squared. So -3 times -3 is what?
9.
What kind of 9?
9.
I don't know.
Negative times a negative is a positive, right?
It's 9.
So we have collectively come to the decision that it is 9 positive. Now in your calculator, -3 squared.
That's gonna be wrong, isn't it? It's -9. What?
Hey.
What the heck?
Everyone's like, all right, either the calculator's wrong or Sullivan's messing with me.
Solve it, buddy. Why?
When you type -3 squared The order of operations says this is a -1 times 3 squared. The calculator is not wrong. That is user error. What should it do first? In the order of operations, what should it do first? Exponents come first. 3 squared is 9. 9 times a -1 is -9. Versus, what if I did this? Now I want you to retype it. Parenthesis -3 parenthesis squared. Now it should say +9. Because now you're telling the calculator, no, you need to do a -3 and square it. You need to multiply the 3 by -1 and then square it. So in big honking neon letters somewhere on this page or the first, parentheses. I told you this since first semester. Parentheses keep us from screwing up negatives and exponents. You need to type this with parentheses, or you will do these problems wrong. I guarantee it. When I want to type 2x squared in my calculator, I need to type 2 parentheses squared, and I'm going to plug my number in those parentheses. If you don't use those parentheses, you will get these wrong. Like, I'm just telling you, you are going to get it wrong if you don't use parentheses. And it's because of the order of operations. You're going to be like Aunt Kathy on Facebook looking like an idiot because she doesn't know what parentheses are. Okay?
Stop calling out my mom. I know she's stupid. I know she's crazy and drives everybody in my family crazy, but gosh, I got everything.
That's a little on the nose there. So if you would please, calculator, I want you all to type these. Oh, another thing, I'm going to break my own rule here. I actually go on a rant about this in Algebra 2 and Pre-Calc. Function of x is a fancier version of y. Okay? F of x is a fancier version of y. Here's what's really happening. I know you saw function notation last year. This is the name of the function, like Fred. Fred will do this to everything he sees. The thing he does is the equation part. It's the rule. Fred's rule is that he eats everything he sees. The output is y. Okay? You all know, or you've heard the phrase about cut out the middleman. Okay? Example of this years ago would be I had, what was it? There's 2 kids in class. It was something about every Thursday. Hey, did you know that Thursday is Throat Punch Thursday?
What? I gotta tell my brothers that, so I'm
Okay.
gonna throw a punch him.
Like, hey Kevin, did you know that Throat Punch or every Thursday is Throat Punch Thursday? Oh, okay. And then behind me I hear, okay. So we had this idea that if it's Thursday, then it's Throat Punch Thursday, then Kevin gets throat punched. Okay, chill out here. But you know about cut out the middleman, right? If it's Thursday, then it's Throat Punch Thursday. If it's Throat Punch Thursday, then Kevin's getting punched in the throat. So I was able to randomly kind of get this kid by just, I do a thing, I want you all to do this problem, everyone's starting working, and I come over here to my desk, and as my back is turned, I would say, that's weird. It's Thursday today. With my back turned, and then behind me I would hear, because if it was Thursday, you could cut out the middleman and Kevin was getting punched. Okay?
Wait, I also want a wild guess. Was it Sorsic?
No.
Oh, okay. Man.
F of x, function of x. This is a fancier version of y because it's the name of the function. It's the name of the rule. But after I do the rule, I get a y anyway. So I can cut out the middleman and just replace it with y. And I know this might look more complicated, but you can literally just come over here and replace this with a big old y. I know it says x and f of x, but that can just be replaced with y. Hey, it's Thursday. Okay, replace it with y. Cut out the middleman. Now, I want you to start plugging these numbers in and use those parentheses por favor. If I plug a -2 in here, what comes out? 8 or -8? Okay, I'm checking.
Yeah, I got 8.
Ooh. So I've now heard a -8, a +8, and a 4. 2, parenthesis, -2, parenthesis, squared.
It's 8. It's positive 8.
Okay. I'm just double checking. Whatever. We got 8. Okay. So I'm going to come down here and put 8. Put in -1. Replace it. Okay, so you're constantly replacing that with whatever the value is. I put in a -1.
Oh, and she's throwing weird things at me.
Please. You can take a lap and mellow out there.
No.
You sure?
Yeah.
Because -1 squared is 1. 1 times 2 is 2. Plug in a 0. 0 squared is 0. 0 times 2 is still 0. Watch what happens when we go over to the positive side. 1 squared is 1. 1 times 2 is 2. Take a wild guess what's going to happen when I plug in 2. If I plug in a 2, 2 squared is 4. 4 times 2 is 8. So I know that says f of x on there, but this is just your regular old xy table. Plot your points. And when you're done, it should make a U. We call it a parabola. I'm about to graph things, and I sometimes screw up graphing things. Maybe I should write this old friend next to it. How many of us goof coordinates? We go the wrong direction. Maybe you put that old reminder next to it. So that says left 2, up 8. That says left 1, up 2. No left or right, no up or down, 0, 0. Right 1, up 2. Right 2, up 8. Now, when you make these graphs, they're parabolas. Parabolas are curvy. Don't make it a V. Okay? That's literally a different type of graph. It's an absolute value graph, and we are going to do them in here. Okay? This is absolute value, like this. This is x squared. So when you connect the dots, try to keep it curvy, okay? Like Beyonce. Got to get some curves on it, girl. We want Beyonce, not Amanda Seyfried. How about that? Okay. Amanda Seyfried's like 96 pounds and looks like a pug.
Why did they kill that? Because it was hot.
Okay. Where did this thing hit the x-axis? So there's only one solution and it's when x is 0, because that's the only place it hits the x-axis. Okay? So some of the time we're going to have to make the table, graph the thing. Other times, they're going to have everything already laid out for us, and you're going to have to tell me that vocabulary business about it. Come on, Frank. There you go. Identify any zeros. Remember that the zeros are the x-intercepts or solutions. So, where does this thing hit the x-axis? Okay, there are two zeros. They are at -2 and +2. There you go. Like, it's that simple. Identify the maximum or the minimum. Does this thing have a lowest point or does it have a highest point? It's got a lowest point because the graph opens upward. If it opens upward, you see what they mean by it opens. Literally, there's an opening there. Well, if this is the lowest point, is it a maximum or a minimum? So this is a minimum. If it looked like this, it would have a maximum. Okay? Now, the way that I say it is that coordinate, 0, -8, my minimum value, what was that lowest value on the graph? -8. And it happens when I hit the x equals 0 button. I press 0, it tells me -8. That's the smallest number it'll ever tell me. There's an x equals down here, and it's supposed to say 0. So when you have a maximum or a minimum, you say maximum or minimum of number when x equals number. Okay? So those are really the two things we're doing. Graph by table, tell me stuff about graph. You got, right? I went too far. There we go. Okay. 1, 2, 3, 4. 1 and 2, graph it by table. 3, 4, it's already graphed, you tell me stuff about it. And then, you got two teachers in here. Don't just sit and stare at it. Ask questions. So,
I got a question. So, like, for this one, since the x is right here, would I just parentheses right
yep.
there? Okay.
Oh, something we found yesterday. When you're doing this, be careful. I don't want to do... Which of those is right?
I'm gonna assume the left.
Okay.
That one.
Everywhere there was an x, we replace it with parentheses. The squared is outside of the x thing. So, no bad. It's like...
Are you making like a little hand jerky on a smart letter?
Yeah, you tried to do that.
Oh, it looks gorgeous.
Actually, that's pretty good. For smart board tricking.
I would just like to say that smart board tricky thing.
It looks really good.
I'm trying... That's terrible. I'm trying to do the drug thing. And they died. It's bad. Okay? Don't do this.
Dude, I remember being traumatized from that.
Okay? I absolutely love the movies. The Croods. I ain't gonna lie. Papa Bear gets a little emotional when it's like, "You're not coming, are you, Dad? When you make it, so will I."
I just imagine Saul just sitting on his couch with his kids like falling aside. While Connor's like just sitting there.
Yep. Okay. These four, please. Graph by table, use the parentheses, use the calculator, make sure that you are double checking stuff, maybe with your table mates.
Where'd you get the numbers for X?
They chose them.
I mean, but like for the Y.
You plug it. That's the whole thing we just talked about. You're going to plug it in. You're going to plug in something squared minus 9 into your calculator. You plug in -4.
So you just do that over and over.
Yeah.
Okay.
Just like our tables from first semester. It's just the equation's uglier now.
Oh yeah. Second oldest.
Only one of these is wrong. This guy. Try it again. Parenthesis 0 parenthesis squared minus 9. I think. I bet you just forgot the minus 9. Yeah. Okay. All right, now plot these points, and if you need to put this guy back on there.
So, okay, so for X right here?
So x, y.
Yes. So,
-4 up 7. And it's halfway through the box because they're going by 2s. There you go. When you're done, it should look like a big U.
There's this person who lives down by They have a
Minimum for a horse is 2 acres. That's South Dakota law. That's why there's a lot of subdivisions that are at 2 acres.
I have a whole field behind my house.
I have a class full of kids that need to do math problems.
Oh, sorry.
That's not bad.
I don't know. Oh. If it is, then we'll pull it. So,
Do I put these numbers
Yep.
in the parentheses?
Yeah.
Oh, I just came up with random numbers to put.
No,
Doing what I was
they're telling
doing
you what
last
numbers to
time.
use.
Okay.
Yep. Now, later, if you have to make your own tables, then we'll probably choose like -3, -2, -1, 0, 1, 2, 3. He has them. Oh, that is so pointy. It's so pointy. Eat something, girl.
What? Don't bully me. That was personal.
Here. There, 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 there.
Oh, all right. I'm picking up.
That.
So, and then when you do this, you just write down where it hits.
And it hit the x-axis here
Negative.
and here.
So I just say -3, 3.
Yeah.
Oh my God, it's so easy.
So, we already got negative x's right there.
Mm-hmm.
So that just turned into a positive.
No, be careful. That negative, and then the x.
Oh, so we put a negative in front of that.
Uh-huh. Because now when you plug a -3 in there, do you do the times negative or do you do the squared first?
You do the squared first.
Uh-huh.
That.
That, and then it turns it negative. That's why those parentheses are so important, is because this parabola is supposed to look like this, but if you didn't, your parabola would be completely the opposite direction. Parentheses. Yeah.
Did I do something wrong? Because I'm doing this one, and that's not even on there. So I don't know if I.
+4. Well, we'll pull that one out.
I was like looking at it. I was like.
That means it's bumped up since I did my purge.
I looked at it, I was like, that's historical.
It was probably just under $5 when I did the purge.
It hasn't had reprint, so.
Yeah.
And it's in a lot of playing Commander.
Which I have opinions about.
Not crocodile, not like crocodile.
People doing like consultation Thoracle combos is just that's magic on easy mode.
It's just like Quadratics, you know.
Okay, I'm tough.
Me?
Twice. Okay, cool. So it's negative from
Sure.
your numbers were.
Oh, yeah, sure.
You have to be careful of the negative outside. So if you look at that,
Sure.
it's negative, you've got a square line up. Now, in that case, I mean, 0 squared is 0. So this is,
What, your
but
boyfriend?
let's go back and check. Now we do first four.
No, I know that you had one of them because you kept talking about him all that way. Sorry, last week, no, yeah, last week.
Okay, oh, you're doing good. I'm in the
All the shit.
I use your order.
It's only the same price.
Alright, finish those off. We'll be back in 2 minutes.
What do you mean, finish them? What do you mean, finish them?
Alright.
I know nothing. See, look, I know nothing.
Yeah, it's such.
Yeah, exactly. I did it.
Did you do it? Got
What? No, I didn't. Stop. You're making this. Yeah, no, I can. How do I do
So I'm graphing it.
this?
So,
Really?
Yeah.
You're gonna break my butt. You're gonna break my butt.
oh, it's a maximum.
I'm not gonna let you break my brain.
Okay, so don't like. I just don't. It's like stop.
But you ain't gonna. One day, you'll never come.
This is for time.
No. Did he actually? Did he actually say that? One day, we'll
All the
never.
last okay, so that's max.
I don't know. Okay, this, good here, show me how you did this.
Everything but the.
You forgot the square.
Yeah.
That
Yeah, my brother never did. It just scared me when I get scared.
Now when you should see.
No, you're good. So on these ones, I'm looking at this
Start.
one, and it's
First
got
point is up here,
and
you know, your max.
It is,
here.
but I didn't think it would know where, so.
There are 2 zeros. Half. Negative 2.
Why?
So like this one,
Wow.
where does it hit you?
No, that one's good, this one's,
So, yeah.
if that was a point,
What do you mean?
Yeah, it's kind of.
and your other one's gonna be three.
Oh, did you?
I can just see you.
Yeah. So where does it cross? -2 and 2, so that's what you would put down here.
Is it going okay? Nah.
Yeah, no, it's just kind of hard.
Parentheses.
Parentheses doesn't always solve that though.
Oh, yes, it does.
There's negative numbers, but the X thing says negative, so.
Oh,
That makes sense.
that makes more sense.
Thank you.
The X itself poofs into parentheses.
That makes more sense.
Thank you. Okay, ask your question.
Does that look, at least, did I kind of get the concept right? Because I feel like I did.
Yes. Thing minimum at 924, yes. And 5, -1, maximum of 4 at 0. Crushed.
And then, can I go chat with Kaylee? Fully behaved, I swear on my life.
All right.
Yay!
Is there? Okay. What I just had up there is these get weird if you try to combine the negative with it. But if I do this.
So you've been
Oh, I forgot the negative, my bad. That's probably right.
Uh-huh.
Oh, okay.
So you're plugging a negative in here, and then by using parentheses, your calculator's saying negative 3 squared is 9.
Okay.
Negative 9 plus 4
Yeah.
is negative 5.
Okay, yeah, I think I did it wrong. Thank you.
Okay, we need our parentheses. Okay. Yo.
So I basically got everything down. Let's get like these two.
Okay. This point is the lowest the graph ever goes. And if I'm saying lowest, maybe that's saying down, right? Well, down is on the y-axis. So you look at the y part of the coordinate for the lowest it ever goes.
Okay.
The lowest it ever went was negative 24.
So it would be the negative.
Mm-hmm. And it happened when I pressed this button. So you go find that point. You're right, it's a maximum. It's at 0, 4. So 4 is the highest it ever goes when I hit x is 0.
Oh, so you just okay. So if it's the lowest one, you write the y here.
Uh-huh.
If it's the highest one.
You write the y there. Yep. Your maximum or your minimum is your y value. How? Because y's are high and low, up and down. Okay. All right. Looks like we got it good. So around the room, I'm seeing good stuff. So I'm going to kind of turbo version these. Remember that this is written as parentheses squared minus 9, and then I put my number in here. So negative 4 squared is 16. 16 minus 9 is 7. Negative 3 squared is 9. 9 minus 9 is 0. 0 squared is 0. Minus 9 is negative 9. Is 0 is 7. Be careful on your graph. It is going by twos. So left 4, up 7 is halfway through the box. Left 3, 0. No up or down, or sorry, no left or right, down 9. Now, some of you, you don't have to be an artist, but y'all, when I see this, we got problems. That is not a parabola. That's just a really bad absolute value. Some of us are trying to do this like wishbone thing, where it's like the bottom of a shield. Okay, try to keep it curvy. Suppose I shouldn't make that particular gesture in front of a room full of teenagers.
Wait, what do you mean? I didn't even see.
I'll explain it to you.
I didn't even see what he did.
Okay. They don't have to be perfect. You don't have to be an artist, but try to keep it curved at the bottom. Okay? It hits the x-axis in two spots, -3 and 3, so those are my zeros or solutions. Okay? Move it over. Some of us were goofing this until I showed you where those parentheses go. Frank?
What you mumbling over there?
Stupid dragon.
Stupid dragon.
Yosemite Sam. Y'all ever seen? Yeah, probably not.
I have, but I'm just saying.
Yeah.
Frank is not a dragon.
Frank.
He's just wanting to think right now. He's just having a bad day. So.
I'm telling you, he's distraught that it's like the only person who's ever given him any attention.
So anyway, when I plug in a -3, careful about those order of operations. A -3 squared is a +9. But now that I have my parentheses there, that says -9 plus 4. Says -4 plus 4. Says -0 plus 4. And so on and so on. So I'm going to be at 0, 4, plus or minus 2, 0, plus or minus 3, -5. Again, connect them. Try to keep it curvy. I usually miss the dots on the right side.
Why?
I just do.
You're solving special.
I would like you to draw every one of your points like this, right next to it.
Yeah, I do.
Because that's what it's like trying to draw on a smartboard from the side. Okay. There are two solutions. Where are they? Okay. But once you saw that that negative comes out in the parentheses, did it go better?
No.
Everywhere there's parentheses, poof, I now have x. Everywhere there's x, poof, I now have zeros, or parentheses. Where's this thing hit? -3 and 3. It's just look at it, right? All right, here's the vocab part. Does this have a maximum or a minimum, a high point or a low point? The minimum value, when I'm talking about maximum and minimum, it's up and down, right? Well, up and down is the y-axis. So I'm looking at my vertex of 0, -24. If I'm looking at the y-axis, I'm looking at the y values. The lowest it ever goes is -24. That's my minimum. There's a negative there. And it happens when I plug a 0 in for x. Okay? The next one. Does it have how many zeros?
Yeah.
Okay, happens at -1 and 1. Does it have maximum or minimum? Maximum. Over here at 0, 4. Maximum value. Sounds like you just sniped someone from across the map. Right?
Why are you playing Mortal Kombat?
No,
So-
that's Call of Duty.
It's the voice, not what he said.
Oh, you see that Call of Duty has signed a contract with Nintendo now? So they're going to be able to go cross-platform.
No, they're not. They're probably not. Nintendo has made tons of cross-platform games, and specifically
No,
does
like-
not make them cross-platform.
They made the announcement of merger licensing with Microsoft.
Yeah, but the licensing cross-platform.
Now,
honestly,
I don't know if they'll be able to play across-platform, but I could swear the announcement said yes. Did we?
We did not.
Frank! There we go. Frank?
Why are you blaming Frank for your mistakes?
Because I'm doing the thing and Frank isn't helping.
That you're on hand. There you go.
It's okay.
Shut up.
But did you just
All
tell
right.
me to shut up?
No, I didn't. 5.
Okay, so
Be careful. Only where the X is do I get parentheses. I want you to write above this. How are you going to type it? Just like I've been writing it up here with parentheses and a blank spot. You write it. Show me that you know where your number is going. Okay, after you see it enough times, parentheses here. Think you could fill in that table? All right. Speed run it. Get that table filled. Okay, don't speed run it. Take your time. Be careful. We screw up when we rush, so just do it for real. Nora, I did see you were here this morning.
Really? They left me on red. They never told me that.
She was here this morning. You said she's got cookies.
Oh.
Yeah. Just if you haven't seen her in the hallways. I saw her here this morning. Yuri?
Oh. Oh. I thought you said you were, and I was like, are you going to commit nepotism for me in pre-cal?
No.
That's what I thought. I was like, what the?
How'd we do?
Oh, wait, no, never mind.
Okay. Maybe I did them wrong. I don't know. I'm tired. If I plug in -2, -2 squared is 4. 4 times -2 is -8. -8 minus 4 is -12.
That is correct.
Okay, we'll try again. Maybe I goofed. Y'all, I'm on super sleep deprivation mode here. Okay, I plug in -1. -1 squared is 1. 1 times a -2 is -2. -2 minus 4 is -6. You owe me $2. I'm dumb enough to let you borrow 4 more. We're at -6. Okay. We checky. -2 down to 12. -1 down to 6. 0 down to 4. Down to 6. Down to 12. And it should make a U. Okay.
Wow.
Now, we ran across this at the beginning. Where does this thing hit the x-axis? It doesn't. So what are the solutions? There is none. There are no zeros. There are no x-intercepts. There are no solutions. How do we feel about this? This is going all right? Can I set you loose, or do we need some more practice? Okay. 26 minutes to get her done.
All of it. All the above. All the
Buddy,
Alright.
you know how this works. Okay. 1, 2, 3, 4, 5, 6. Oh, let's go do the word problem one together.
Oh, yeah.
Because I know how y'all freak out about words. Okay, let's go forward a little bit to number 10. Object is dropped from a building. The height in feet of the object given time in seconds is modeled by this function. Graph this function. What am I supposed to be doing here? H is -9 parentheses squared plus 36. Isn't this just the same thing?
Yeah.
It's just bigger numbers. Now, be careful. I do want to get the numbers in this table and I want to graph them together because look at the scale. Okay, they're going by tens, which means we're probably going to have to ballpark some of our points. So plug in here your values. Plug in -3. -3 squared is 9. 9 by -9 is -81. -81 plus 36 is a negative 50.
45.
45? Okay. Plug in -2.
0.
You sure about that?
Mm-hmm.
Yeah, you're right. Okay, plug in a 0.
Oh, come on.
Well, those should be the easy ones, right? It just,
36.
this becomes nothing.
Just 36.
And I hope we're seeing by now that as long as this thing doesn't move left or right, they're going to end up being symmetric. In fact, these parabolas, they got special features to them. And one of them, 36 is about halfway through the box. 0, 0, 45 is about halfway through the box. Connect dots. These things got special features, and one of them is called, maybe you remember this from your math or art classes, an axis of symmetry. Do you remember ever doing that in a math or an art class where you'd mirror something from one side to the other, like over a dotted line?
Yes.
Make different illustrations, make the other half of the butterfly, whatever it was.
Yes.
Okay, parabolas have that. Like, it's an actual mathematical feature on it. Axis of symmetry. Okay, in fact, right there above Kalen's head, parabola, axis of symmetry, it's even got a special formula to find it. So there's a lot of stuff about these that we don't know. There's even stuff about it we keep hidden from kids all the way up until pre-calc. So right now, I just want to make sure that you can graph them, and that you can tell me maximum or minimum and solutions. Run with it all the way to the stop sign. You will be back in here on Tuesday, and you should be hopefully done with this. We seem to be doing well enough that I think you could blast through. Okay? I'll leave you to it.